Hello everyone, this is Varun. Welcome to Aerospace Structures. Today we are going to discuss about the airframe loads. That is second part of airframe loads, that is wing structures. Okay, uh, when you consider an aircraft, wing are the major source of the lift. Approximately nearly 90% of the lift force is generated by the wing, and depending upon the design. Depending upon the wing design depends upon size, weight, speed and other factors. You might have known already that the lift L is equal to CLS, that is surface area, into 1 by 2 rho U square. U square is the flight speed and CL is the portion of lift. And moreover, in order to have a maximum lift, what we need to have is that we need to have a maximum area, that is the size is one of the more important parameter. Apart from this, the weight of a structure is one of the most important thing. If it is a more weight, the airplane cannot fly. So there should be an optimized weight in order to carry a lift, to generate a lift. Okay, and the other factors like stability and other things also influence the wing design. The wing of some aircraft are of cantilever design and they built so that no external bracing is needed. And when you consider an aircraft, when you observe an aircraft, the wing design might be of cantilever type or of semi-cantilever type. Other aircraft wing use external bracing to assist in support of the wing and carry aerodynamic and landing loads. And moreover, in order to give a strength to the wing structures, the external bracing is provided. Okay, this is a cantilever type of wing structures. You may see two different type of airplanes. One is the high wing and one is the low wing. And this is the full cantilever type. You can observe that there is no bracing, and this is a semi cantilever type of constructions. And this is you can see these are the braces which are supported from the fuselage section. And there is another type of construction. You can also observe this the extra thing what we get is the other element which is used to support when the wingspan is long, and we use such type of constructions, and this is called as the biplane. Next, when we go into the internal structure of a wing, when we remove the outer part of a wing, let us identify what are the components are within the wing. Here, this is the wing tip, and you can see this, it is rounded, and you can observe here the longerons which are running from one end to the another end of the wing, that is along this span-wise direction. And we have a provision for the full fuel tank, and these are the wing flaps, these are the control surfaces, wings flap and ailerons. We are not going to discuss about the wing flap and aileron. And the most important thing what we include in our topic is the spar. The spar which is running from the fuselage section to the wing section, and these are the called as the ribs or bulkheads. For example, when you construct any structure or civil structure or some other structures, what we do is that we try to improve the strength in longitudinal direction and as well as the lateral direction. In some cases, we also increase the strength in the diagonal direction. In the same way, what we do is that uh, we increase the strength of a wing by providing some type of geometrical structures called as the ribs, spars, and and other stringers. And you can see that from the holes of the ribs, these stringers are passing through this. These are just like ailerons in an aircraft structures. And this is the spar. For example, when you are constructing any civil engineering structures, what we do is that if we need to have a construction like this and there is a load carrying capability, what we do is that diagrammatically I'll be explaining this. We need such type of structures, and this is a wall and this is some concrete structures. In such type of thing, what we do is that we put a beam along this direction. As a result, when a load is applied in this direction, some part of the load or major part of the load is carried by these walls. And in similarly, when you take an aircraft structures, these parts which runs from the fuselage to the wings will carry a load to the fuselage and provide the strength. Okay, the internal structure is made of spars and stringers running spanwise and ribs and formers running chordwise, that is leading edge to the trailing edge. When you look into the internal structures, spars, this is a spar, and you can see that this spar is running from one end of the wing to the another end of a wing. And similarly, these these stringers are also running from one end to the another end of the wing tip. The spars are principal structures members of the wing. When you take the case of the spars, these are one of the principal structural elements. The skin is attached to the internal members and may carry part of the wing stress. This is a wing without a skin, and this skin is covered along these ribs and riveted on the ribs and as well as the uh, spars and the stringers. When a load is imposed on the skin, this load is carried by the ribs and it is transferred to the stringers and spars. Okay, from the skin they transmit to the ribs and from the ribs to the spars. For example, when there is an aerodynamic load or when there is an inertial load, this inertial load or the lift, more generally the lift, is produced on the skin section, and the load which is carried by the skin is transferred to the ribs and to the spars and the stringers. The spars support all distributed load as well as concentrated weight such as fuselage, landing gear, and in multi-engine aircraft and nacelles and pylon. For example, when you take a single engine aircraft, the power plant is installed into the fuselage section. But when you take the case of multi-engine aircraft, the engines are installed on the wing structure, and this wing structure should carry, that is the ribs and the spars should carry spars and the ailerons. Sorry, the spars and the ailerons should carry all the weight of a fuel tanks and power plant and weight of the structures. Okay, coming to the wing configuration. Depending upon desired flight characteristics, wings are built in many shapes and sizes. For example, just you observe a civil aircraft wing and a fighter aircraft wing. What you actually observe? First thing what you observe is that in fighter aircraft, we have a delta wings, but in civil aircraft, which are flying below the soaring speed, have tapered or some sweep back wings. Wings are also designed to provide certain desirable flight characteristics such as greater lift, balance, and stability. Apart from providing the lift, and the other functions of the lift is that the stability and balance. These are the most important characteristic for any of the aircraft. Lift is not only the major source. The lift might be one of the major source, but apart from this, it should satisfy the condition of stability and balance. When you consider the wing platforms, we have the following wing platform: straight wings, elliptical wings, tapered wings, sweepback wings, and delta wings. These are the wing geometries. This is the straight wings. These are commonly employed in during the First World War, and today also we have such type of straight wing for low speed aircraft. And next comes the elliptical wing. You can see that it's an elliptical platform section when it's viewed from the top view. And the major advantage of this elliptical wing is that it reduces the downwash. Right now, I can't explain what is the downwash. And next, the tapered wing. Since the cost of production and there is other design consideration for the elliptical wing, so in order to optimize between the straight wings and the elliptical wings, we have a tapered wings, which is an optimized version between the straight and elliptical wings. As the speed of an aircraft increases because of some difficulties in breaking the sonic barrier or some other things, we have a swept back wings. Still, this since even the swept back wings have some limitation on the speed. And next we have went to the delta wings. This is the development of the wings and the wing platform. And the major thing is that for a fighter aircraft, when the speed is increased, we need to have a thick wings rather than thin wings. Okay, when you look into the wing structural parts, we have spars. Already I have shown you in the diagram. Ribs or bulkheads. Bulkheads is a common name taken from the uh, fuselage section. Stringers or stiffness, which is similar to the stiffness in a fuselage. Already I have discussed the function of these things. And next, coming to the spars. Spars are principal structural members of a wing. They corresponding to longerons of a fuselage, and moreover, they carry the major part of the load. And similar to longerons in fuselage, these spars are of same function. They run from one tip to the another tip of an wing. They run parallel to the lateral axis or towards the tip of the wing and are usually attached to the fuselage by wing fittings, plane beams, or a truss type. And I'm not going to discuss about the wing fittings and plane beams or other type of things. The accept it for granted, these longerons are attached to the fuselage. Okay, structures may be designed so as to consider fail safe in other. Okay, what we do is that the major aim of a structural engineer is that each and every component in an aircraft should carry a load, or it should transmit a load from one member to the another member. And moreover, if one part of a structure fails, and the load should carry by the other structures, so that the aircraft is safe from the danger. You can see that different metal spars which we have employed in during the early development of flight, we have used the wooden spars. Right now, wooden spars was not used, but RC we are using that in RC aircraft. You can see that this is a box type, and this is a tube type, and we have an I section type, and as well as we have another different type of section. And you can clearly see that this is these two are the I section. These are the it has some different type of geometric structures. Okay, next, coming to the wing grips. When you observe the wing grip structures, it is similar to the shape of an airfoil, and this wing grip provides an aerodynamic shape as well as it carries the loads which is imposed on the skin. The skin of an aircraft is riveted on this wing grip, and moreover it is also riveted on the spars and other things. They usually extend from wing leading edge to the rear spar or trailing edge of a wing. When you look into the geometrical structure of a wing, these ribs are running from the leading edge to the trailing edge. The ribs gives wing a camber shape. Okay. Uh, and this is a schematic of a wing with along with spars and the wing ribs. And there is no stringers. You can see that the stringers are attached. Okay. Thank you very much. This is Varun Voriganti signing off.
Like, share and subscribe. Hit the bell icon for more updates.